Let us start our lecture today. Let us start our lecture today. So in the previous classes, we learned about Laplace transform, right? So today we're gonna try to understand how to use Laplace transform to solve differential equation. Right? So using Laplace transform to solve differential equation. Right. So first we have the theorem. So the theorem says that the Laplace, the first thing is the Laplace transform of f prime will be s times the Laplace transform of f minus f0. So this is x times fs minus f0. All right? This is the formula that you compute the Laplace transform of the derivative. This is something that we learned in the first lecture. So if you want to compute the Laplace transform of derivative of the function, what you do is you multiply s to the Laplace transform and you minus that with f0. All right? This is the theorem that we learned. So now if you continue to use this formula, you're gonna get the Laplace transform of f second will be s squared Laplace transform of f minus s f0 minus s f prime at 0. All right? So the next step is to compute the Laplace transform of f second. The Laplace transform of the second derivative will be s squared times the Laplace transform of f minus s times f0 minus f prime at 0. Right? So which means that you don't, when you try to compute the Laplace transform of second derivative of a function, you can compute the Laplace transform of that function. So what you need to know is just the Laplace transform of that function. And the third one is Laplace transform of the nth derivative of f will be s power n. So here I want to write this like s squared fs minus s times f0 minus f prime at 0. So this will give you s Sn of fs minus s minus 1 f0 minus Sn minus 2 f prime at 0 minus Fn minus 1 f0. All right. So this is the general formula for higher derivative of Laplace transform. Right. I explain again. So in the first lecture, we know that in order to compute a Laplace transform of the derivative of function, what you do is you multiply the Laplace transform of that function with s and you take difference with f0. So this formula has a more general formula, which is following. The Laplace transform of the nth derivative of function is going to be Sn times the Laplace transform of that function minus a lot of values of the function at the point 0. Right? So here you have Sn minus 1 f0 minus Sn minus 2 f prime at 0 minus Fn minus 1 f0. Right. Questions? It's clear? So the power of this formula is that you transform derivative and you remove it. Right? So this formula allows you to remove the derivative of a function. So to remove derivative. Okay, so now we're going to use this formula to solve differential equation. Application. y prime minus 3y is equal to 0, in which the initial condition is given to be 7. Alright, so now we want to use the Laplace transform to solve this equation. You have y prime minus 3y is 4, and then y0 is 7. So what I'm doing now is that I'm going to Laplace transform both sides, right? I have Laplace transform of y prime minus 3y is going to be the Laplace transform of 4. Right? It's clear? Now, I Laplace transform both sides, and I have Laplace transform y prime minus 3y is Laplace transform of 4. So Laplace transform of y prime minus 3 times Laplace transform of y is going to be Laplace transform of 4. Alright? It's clear? So this is a completely different method in which you use Laplace transform to solve differential equation. To use Laplace transform to solve differential equation, what you do, the first step is always to Laplace transform both sides. On this side, you have Laplace transform of y prime minus 3y is Laplace transform of 4. This guy is going to be Laplace transform of y prime minus 3 times Laplace transform of y. So what is Laplace transform of y prime? Yes?
Is it s times the Laplace transform of y minus y evaluated at 0?
Yes. Can you say the back of paper, please? Right, so the idea of using Laplace transform is to remove the derivative, right? So here you have a derivative, you don't like it. So what I'm doing is I'm going to apply the formula here so that I eliminate the derivative. So now I'm going to have Laplace transform of y prime is s times the Laplace transform of y minus y0. What is it? And so I use this formula here. So what is this formula? S times Laplace transform minus y0. Yes?
Is it y for s minus 7?
Right. Yes, but so yes, can you say the back of this? So now you have to replace y0 here first, and you plug this back to the equation, right? So you have Laplace transform of y minus 7. All right? So you replace the y0 first into this formula, which is 7. So I have it here, and now I'm going to plug it back to this equation. Right, so I have s times Laplace transform of y minus 7 minus 3. Laplace transform of y is Laplace transform of 4. All right? So how can I simplify this equation? What is the Laplace transform of 4? Yes?
4 over s.
Yes,
because
can you
we pulled 4 outside.
Can you sign the back of this? Right, so you know that the Laplace transform of 4 is 4 over s. All right? Now, what is the next step? Anyone can guess? Yes?
Do Laplace transform of y.
Yes, can you sign by the paper, please? So everything here is explicit except the Laplace transform of y, right? So what you do now is to solve for the Laplace transform of y. All right? So here I'm going to group s minus 3 to the Laplace transform of y. So I have s minus 3, Laplace transform of y minus 7 is 4 over s, right? now I have to solve a first order linear equation for the Laplace transform of y. So here I have s times Laplace transform of y minus 7 minus 3 times Laplace transform of y is 4 over s. I group s minus 3 with the Laplace transform of y, and then the minus 7 is going to be here, and this is going to be 4 over s, right? So let me continue here. All right, so now I have s minus 3, the Laplace transform of y, 7 plus 4 over s. So what is the value of the Laplace transform of y? Yes?
Do we divide both sides by s minus 3 and take then the inverse Laplace transform of both sides in order to find y?
Yes, please hand back the paper, please. Right, so now I can find the Laplace transform of y, right? By dividing both sides by s minus 3. And y will be the inverse Laplace transform of 7 plus 4s over s minus 3. Alright? Explain again. To solve, so the key idea of solving a differential equation using Laplace transform is that by using Laplace transform, you can remove the derivatives, right? So in this equation, you have y prime minus 3y is 4. What I do is I take the Laplace transform on both sides. By taking the Laplace transform on both sides, I can transform the derivative, right? So when I do the Laplace transform of the derivative, the miracle is that the derivative goes away. And that turns the left-hand side into a linear first order equation. And you can solve it, right? So after you solve the right-hand side, you have that the Laplace transform of y is going to be 7 plus 4 over s minus 3. And of course, now I have to take the inverse Laplace transform of this guy. So how do I do that? Yes?
You can split it up into 7 over s minus 3 and then 4 over s minus 3.
Right. Okay, so the back of paper, please. So now I'm going to split it up. Right, so I have 7 over s minus 3. This is one guy. And the other guy is minus 4 over s minus 3. Alright? It's clear? So here you have two terms, 7 over s minus 3, so I split it. And then the other guy is 4 over s minus 3. So how can I compute the Laplace transform of the second guy? Yes?
We use partial fractions.
Yes, can you send back the paper, please? So again, this guy I'm gonna split it. Right? 4 over s minus 3 will be a over s plus b over s minus 3, and this is equal to a s minus 3 plus bs over s minus 3. All right? Which means that 4 is equal to a s minus 3 plus bs. So how do I find a and b? Yes?
You may set s equal to 3.
Yes, can you send back the paper, please? So now I set s to be 3. I have 4 is b times 3. So b is going to be 4 over 3. And then now I set s to be 0. Then I have 4 is minus a times 3. So a is minus 4 over 3. Alright? I explain again. Now what I have to do is to find the inverse Laplace transform of 4 plus 4 over s minus 3. Right? So this gives you, so here you have 7s minus 3. So I can split it. have the inverse Laplace transform of 7s minus 3, and the other one is the inverse Laplace transform of 4s minus 3. For the second term, I'm going to split it again. 4 over s minus 3 will be a over s plus b over s minus 3, and this gives me as minus 3 plus bs, which means that 4 is as minus 3 plus bs. And now I've set s to be 3, so when I set it to be 3, I have b is 4 over 3. I'm going to set s to be 0. When s is 0, you have 4 is minus a times 3, and a is minus 4 over 3, which means that 4 over s minus 3 is going to be minus 4 over 3 over s plus 4 over 3 s minus 3. All right? So now I'm going to group everything. Right, so y will be the inverse Laplace transform of 7 over s minus 3 plus the inverse Laplace transform of 4 over 3 s minus 3 plus the inverse Laplace transform of minus 4 over 3 over s. All right? Can you simplify it? Yes?
So the first one will be 7 times e to the 3t, because we know that 1 over s minus a is the inverse Laplace transform, that is e to the at. And then the second Laplace transform will be 4/3 times e to the 3t. And then the last one will be negative 4/3.
Can you stand back to talk about this? Right, so now you know the inverse Laplace transform of this guy, so this is going to be e3t. The second one will be 4 over 3 e3t, and the last one will be minus 4 over 3. I can combine the two first terms, so this gives me 25 over 3 e3t minus 4 over 3. And this is the solution of the equation. All right? It's clear? So from this computation, you see that, okay, you don't have to split this from the beginning. You can put a and b, and then if you do that, you're going to find these two terms all together. Right? So I explain again. So to grow up using Laplace transform to solve differential equation is to remove the derivative. Once you remove the derivative, you can compute the Laplace transform explicitly. So after you compute the Laplace transform explicitly, you can do the inverse Laplace transform, right? So in this case, I have the inverse Laplace transform of this whole thing. What I do is I split it, because here I have 7 over s minus 3, here I have 4 over s minus 3, so I split it in two terms. 7 over s minus 3 plus 4 over s minus 3, right? So, and this term, I'm going to split it again. I'm going to put 4 over s minus 3 as a of s plus b over s minus 3. All right? So after I set x to be 3 and s to be 0, I found b is 4 over 3 and a is minus 4 over 3. So I can split the whole thing into 3 terms. Right? But you don't have to do this from the beginning, because you can set these whole things to be a over s plus b over s minus 3. Then the final terms will be 25 over 3 of this guy and minus 4 over 3 of s. Questions? It's clear? Right, so so if there's no questions, let us try to do another example. So the midterm will be next Thursday. All right, so I put the practice exams online. I put 2 of them. So we're gonna do them these practice exams on Thursday. So another example is this equation example. You have y second plus 3y prime plus 2y is equal to 1. Y0 is 0. Y prime is 0 is 2. Alright? So, what should I do in the first step? Yes?
Take the Laplace transformation of both sides.
Yes, can you sign at the back of the paper, please? The first step is always to do the Laplace transform on both sides. Alright? So, I'm going to Laplace transform both sides. So this gives me the Laplace transform of the left-hand side is the Laplace transform of 1. What is the Laplace transform 1? Yes? Can you sign the back of the paper, please? So the Laplace transform of 1 will be 1 over s. Alright? Right. The right hand, the left hand side I can write this way. So I have Laplace transform of y second plus 3 times Laplace transform of y prime plus 2 times Laplace transform of y is 1 over s. Right? It's good. I explain again. The first step is always to do the Laplace transform on both sides. The Laplace transform of 1 gives you 1 over s. Alright? On the right hand side, I'm going to have Laplace transform of all of the derivatives. The Laplace transform of y second, Laplace transform of y second. Right? So what is the Laplace transform of y second? So I want to know what is this guy. Yes?
Using our formula will be s squared times the Laplace transform of y minus s times y at 0, and then minus the derivative of y at 0.
Can you send back the paper, please? So this gives you s squared Laplace transform of y minus s times y0 minus y prime at 0. Right? So this is formula. So once you see that once you use the formula, you remove all of the derivative. What is left? It's just a Laplace transform. All right? So what is the value of this formula? Yes?
Well, we know that y0 is 0 and y prime of 0 is 2, so that would be s squared Laplace transform of y minus 2.
Yes, can you sign at the back of the paper, please? So this is s squared Laplace transform of y minus 2. All right? So I explain again. I'm gonna do the Laplace transform for the second derivative first. The Laplace transform of the second derivative will be s squared times the Laplace transform minus s times y0 minus y prime and 0, right? I'm gonna use those values, right? So this gives you s times 0 minus 2, and this is s times Laplace transform y minus 2, right? So I'm gonna replace y0 here and y prime at 0 here. So when I replace y0 and y prime at 0, this term goes away and this term becomes 2. So at the end of the day, I'm gonna get Laplace transform of y second is s squared Laplace transform of y minus 2. Questions? Right. So now I'm gonna do the Laplace transform of y prime. What is the Laplace transform? Yes?
It's going to be s Laplace transform of y minus 0.
Yes, can you send it back the paper, please? So this is gonna be s the Laplace transform of y minus y0, and this is s Laplace transform of y. All right? I explain again. The next thing that I do is I'm gonna do the Laplace transform of y prime. The Laplace transform of y prime will be s times the Laplace transform of y minus y0. y0 is 0, so this gives me s times the Laplace transform of y. So what is the next step? Yes?
Do you plug it all back into the original?
Can you send the back of paper, please? I'm gonna plug everything back into the equation, right? So this one, I plug it to the equation, and this one, I also plug it back to the equation. Okay. So when I put everything back into the equation, I'm gonna get s squared, the Laplace transform of y, minus 2 plus 3 times s the Laplace transform of y plus 2 times the Laplace transform of y is 1 over s. Alright? So what is the next step? Yes?
You can factor everything, you can factor out the Laplace transform times y and get like 1 followed up the 1 and then divide that into your set.
Can you send the back of paper, please? So I'm gonna factorize everything that have the Laplace transform of y, right? So this is s squared, then I have 3s plus 2. The Laplace transform of y minus 2, and this is 1 over s. Alright? So I'm gonna have s squared plus 3s plus 2. Laplace transform of y is 2 plus 1 over s. This is 2s plus 1 over s. So the Laplace transform of y is going to be 2s plus 1 over s squared plus 3s plus 2. Right? That's good. So I explain again. So here I have, so after I do all of the Laplace transform, I can remove all of the derivatives, and the equation is now left with an equation for the Laplace transform only, right? So this is the first order linear equation. What I do is I group all of the Laplace transform. So I have s squared plus 3s plus 2. The minus 2 goes here, and the 1 over s goes here. I put the minus 2 to the other side. I have 2 plus 1 over s, and this gives me 2s plus 1 over s, which means that the Laplace transform of y is 2s plus 1 over s squared plus 3s plus 2. Right? So what is the Laplace transform? Yes?
If you take the inverse, the plus on the other side, and just multiply these.
Yes. Can you sign the back of the paper, please? So now the Laplace the y will be the inverse Laplace transform of 2s plus 1 over s squared plus 3s plus 2. Right. So how can I factorize the right hand side? Yes?
You can factor the s squared plus 3s plus 2, and then split the full function into partial fractions with 3 separate terms of s plus 1, and s plus 2.
Yes, can you sign the back of the paper, please? So you observe that s squared plus 3s plus 2 is s plus 1 times s plus 2, right? So which means that 2s plus 1 over s squared plus 3s plus 2 is going to be 2s plus 1 over s plus 1, s plus 2, right? I explain again. So on the right hand side, I have s squared plus 3s plus 2. So I observe that s squared plus 3s plus 2 is s plus 1, s plus 2. Alright? Which means that this guy is going to be 2s plus 1 over s plus 1, s plus 2. So what is the next step? Yes?
You split the function, or you split the use A, B, and C, so you have A over S plus B over S plus 1 plus C over S plus 2.
Can you say the back of paper, please? So this gives me a over s plus b over s plus 1 plus c over s plus 2, right? Because on the right hand side you have, on the left hand side you have s plus 1, s plus 2. This is why I'm gonna split it like a over s plus b over s plus 1 plus c over s plus 2. So which means that this is a s plus 1, s plus 2 plus b s plus 2 plus c s plus 1 s plus 1 s plus 2. Alright? So which means that 2s plus 1 is going to be a s plus 1 s plus 2 plus b s plus 2 plus c s plus 1. Right? When I split this like a over s plus b over s plus 1 plus c over s plus 2, this gives me a s plus 1 s plus 2 plus b s plus 2 plus c s plus 1. Right? Which means that 2s plus 1 is a s plus 1 s plus 2 and all of the other terms. How do I find ABC? Yes?
Is that S equal to 0 and solve for A?
Can you say the back of the paper, please? So now I'm gonna set s is equal to 0. So when s is equal to 0, you have 2 times 0 plus 1 is a times 0 plus 1, 0 plus 2 plus b times 0, 0 plus 2 plus c times 0, 0 plus 1. So this goes away, this goes away. So this gives me 1 is equal to a times 2, which means that a is 1/2. Alright? The first step is to put s to be 0. When n is 0, this guy and this guy goes away. So I get 1 is a times 2, which means that a is 1/2. And the next step, yes?
So that's equal to 2.
Can you say the back of the paper, please? So now you said n is minus 2. So I have a times 2 times minus 2 plus 1 is equal to a minus 2 plus 1 minus 2 plus 2 plus b minus 2 minus 2 plus 2 plus c minus 2 minus 2 plus 1. Right? So the next step is to replace s to be minus 2. Then you have 2 times minus 2 plus 1 plus a minus 2 plus 1. This is minus 2 plus 2. This is minus 2 minus 2 plus 2. This is minus 2 minus 2 plus 1. So when I do this, this guy goes away because minus 2 plus 2 is 0. This guy also goes away because minus 2 plus 2 is 0. So the leftover is just c. So this gives me minus 3 is equal to c times minus 2 times minus 1, which is 2. So c is minus 3 over 2. But what is the next value? Yes?
So S equal to negative 1?
Yes, can you say the back of the paper, please? So you said s to be minus 1. So when s is minus 1, you have 2 times minus 1 plus 1 is equal to a times minus 1 plus 1 minus 1 plus 2 plus b minus 1 minus 1 plus 2 plus c minus 1 minus 1 plus 1. Alright? When I do that, this guy and this guy goes away. So this gives me minus 1 is equal to b times minus 1. So b is 1. Right? After that, I put everything back into the formula. So now I have 2s plus 1 over s plus 1, s plus 2 is equal to a over s, which is 1/2 of s, 1 over s, plus b, which is 1, plus c, which is minus 3 over 2, 1s plus 2. Right? Now I have to take the inverse Laplace transform. So the inverse Laplace transform will be 2s plus 1 over s plus 1, s plus 2. This gives me 1/2 the inverse Laplace transform of 1 over s plus the inverse Laplace transform of 1 over s plus 1 minus 3 over 2 inverse Laplace transform of 1 over s plus 2. Alright? I explain again. So after I do all of those, after I set s to be 0, s to be minus 2, s to be minus 1, what I do, what I get is that 2s plus 1 over s, s plus 1, s plus 2 is equal to 1/2 of 1 over s plus 1 over s plus 1 minus 3/2 of 1 over s. Alright? Now I have to do the Laplace transform, inverse Laplace transform. So the inverse Laplace transform of the whole thing will be 1/2 of the inverse Laplace transform 1 over s plus the inverse Laplace transform of 1 over s plus 1 minus 3 over 2 inverse Laplace transform of 1 over s plus 2. So what is the inverse Laplace transform of 1 over s? Yes? Yes. So the first one is just 1. So I have 1 over 1/2. What is the inverse Laplace transform of 1 over s plus 1? Yes? Yes. Can you sign back the paper, please? The second one gives you e to the minus c. And what's the inverse Laplace transform? Yes?
You're going to get negative 3/2 times e to the negative 2.
Yes. Can you sign at the back of the paper, please? So this gives me minus 3/2 e to the power minus 2. Right. And this is basically the solution. Alright, so the key is always to inverse Laplace transform, to Laplace transform of both sides. So when you do that, all of the derivative goes away, and the equation returns to a linear equation on the Laplace transform. Once you compute the Laplace transform, you have to do the inverse Laplace transform, right? So in this case, I have to do this inverse Laplace transform. So what I do is I split it into the sum of those terms, function that I know their inverse Laplace transforms. So this is 1 over s, 1 over s plus 1, 1 over s plus 2. And when I do the inverse Laplace transform, I have 1 e to power minus c e to power minus 2 t. Questions? It's clear? Right, so let us do another example. So the next example is the y second minus 3y prime plus y is equal to e to the t with y0 is equal to 1 and y prime S0 is equal to 1. Alright. So now, this is the equation that I have to solve. This is again a second order equation. Of course, if you do it in a classical way, like guessing the particular solution, it also works. Right? So in the classical way, you're going to have to solve to guess for the particular solution of the form a times e to the t. This is case number 1, right? And then you solve for the homogeneous equation. But here, if you use the Laplace transform, it is going to be simpler. So now, what I'm going to do is I do the Laplace transform on both sides. Right? So what is the Laplace transform of 3 times e to the t? Yes? Yes, can you say the back and forth of this? So this gives me 3 over s minus 1. Alright? I explain again. The first step is always to Laplace transform both sides. The right hand side, when I do the Laplace transform, I get 3 over s minus 1. Alright? Now let us, so the left hand side I'm going to have Laplace transform y second minus 3 times Laplace transform y prime plus Laplace transform y. And this is 3 over s minus 1. Alright? So, what is Laplace transform y second? Yes?
S squared Laplace transform of y minus s times y0, which is 1, minus y prime 0 equals 1.
Yes, inside back to the purpose. So this gives me s squared Laplace transform y minus s times y0 minus y prime at 0. Alright? So this is s squared Laplace transform of y minus s times s minus 1. Alright? The first thing I do is to I apply the formula. Laplace transform of y second is s squared Laplace transform of y minus s y0 minus s y prime is 0. Y0 is 1 and y prime is 0 is 1. So this is s squared Laplace transform y minus s minus 1. It's good. The next step is to compute the Laplace transform of y prime. What is it? Yes?
It's s times the Laplace transform of y minus y0, which is 1.
Yes. Can you say the back of the paper, please? So this is s times the Laplace transform of y minus y0. So this is s times the Laplace transform of y minus 1. Right? So what is the next step? Yes?
Plug it back
To the equation. Can you say the back of the paper, please? So next step is is that we're gonna plug everything back into the equation. Right. So I have to plug everything back into the equation. I'm gonna get s squared Laplace transform y minus s minus 1 minus 3 times s Laplace transform y minus 1 plus the Laplace transform y, and this is equal to 3 over s minus 1. Right? So, in the next step, I replace Laplace transform y second with s squared Laplace transform y minus s minus 1. Minus 3 times Laplace transform y prime with minus 3 times s times Laplace transform y minus 1, and the Laplace transform y stay the same. What is the next step? Yes?
Factor L the Laplace transform of y and then divide the other side.
Yes. Okay, so the back of paper, please. So now I'm going to factorize the Laplace transform of y, right? So this gives me s squared. This is minus 3s. Minus 3s. squared minus 3s plus 1. Laplace transform of y. Right? And this gives me, I think I make a mistake here, I have minus 2. Sorry. So this is 2. This is 2. Sorry, I make a typo. So this is 2, this is 2, this is 2. So here I have s squared minus 2s plus 1, Laplace transform of y, and the leftover will be minus s minus 1 plus 2 is going to be 3 over s minus 1. Alright? Explain again. So here I'm going to factorize all of the term that has Laplace transform of y. So here I have s squared, here I have 2s, here I have 1. I'm going to get s squared minus 2s plus 1 times the Laplace transform. The other terms will be s minus 1, which is s minus 1 here. So here I have a plus 2. Right? And finally I have 3 over s minus 1. So I'm going to so this gives me s squared minus 2s plus 1 times the Laplace transform of y minus s plus 1, and this is 3 over s minus 1. It's good? Right? So, so which means that s squared minus 2s plus 1 times the Laplace transform of y will be 3 over s minus 1 plus s minus 1. Questions? It's clear? I explain again. So I make a mistake in the beginning. So there's a 2 instead of a 3. Here I have s squared Laplace transform y minus s minus 1 minus 2s Laplace transform y minus 2 plus Laplace transform y is 3 over s minus 1. I group all of the terms that contains Laplace transform y, which is s squared, 2s, and 1. So this is s squared minus 2s and 1. The other terms minus 1 minus s minus 1. So here I have minus s minus 1 minus 2 minus 1. So this is plus 1, 2. And the right hand side is 3 over s minus 1. Minus s minus 1 plus 2 is minus s plus 1. I put minus s plus 1 to the other side. I have s minus 1. Right? So what is s squared minus 2s plus 1? Yes?
S minus 1 squared.
Yes, can you send back the paper, please? So here I have s minus 1 squared. Laplace transform of y is 3 times s minus 1 plus s minus 1. So finally I divide both sides by s minus 1 squared. So I have 3s minus 1 cubed plus 1 over s minus 1. Alright, I observe that s minus 2 plus 1 is s minus 1 squared. So what I do is I divide both sides with s minus 1 squared. So the Laplace transform of y will be 3 over s minus 1 cubed plus 1 over s minus 1. So y will be inverse Laplace transform of 3 over s minus 1 cubed plus 1 over s minus 1. Questions? So what is the next step? That's the next step? Yes?
We use partial fractions to solve on the s over 3 over s plus 1.
So 3 over s plus 1 to the power
So
3.
take the inverse of cost of that for the function, so you have y equals the inverse of cost of all of that, and then you can solve for what's inside.
Yes. But yes, so how can I split this guy?
Using partial fractions,
In which form?
we have s cubed a over s minus 1 plus b over s minus 1 plus c over s minus 1.
But but this is going to be repeating, right? So it's going to be A of s minus 1, B of s minus 1, C of s minus 1 is going to give you the same thing, right? So how do you do that? Yes?
Maybe A over x minus 1 and B x over x minus 1 squared and C x squared minus over x minus 1 cubed.
You don't need to go to cube, right? So, so what I do is I'm going to split this. So first I'm going to split this into something easier first. Can you send back the paper, please? I'm going to split this first into the inverse Laplace transform of 1 over s minus 1. Right. So, so the first thing that I have is I'm going to split this into two easier terms, which is 1 over s minus 1 and 1 over s minus 1 cubed, right? So this is computable, and this is something else. This is the so for this one you cannot split it, but there's a better method. Yes.
Is it because the Laplace transform of t to the n times e to the at will be n factorial over s minus a to the n plus 1? Can we use that formula so we know that because s minus 1 to the 3, so it'd be s minus 1, we can think of that as 2 plus 1. So we know that the inverse Laplace transform, we need to have 2 factorial on the top, so we can multiply top and bottom by 2 factorial. And so the inverse Laplace transform of that will be 3, let me think. It'll come out to be the inverse Laplace transform of 3 times 2 factorial on the top over 2 factorial on the bottom times s minus 1 to the 3, which will be 3 times t squared times e to the t.
Yeah. Yes, this is a very good idea, right? So you know this, that the inverse Laplace transform. Can you sign the back of the paper, please? The inverse Laplace transform of 1 of s minus 1 is e to the t, right? Right. So you can observe that there's a formula that I wrote, which is on the beginning of the class, which is formula. This is the theorem that I have derivative in 3.1.2. Right, derivative. 3.1.2. What we have is that so if you have fs is the Laplace transform of function ft, then f prime of s will be minus the inverse the Laplace transform of ft. Remember this formula, right? So this is what Elena said. So you have, once you have the Laplace transform of function ft, so the derivative of this guy will be minus the inverse Laplace transform t ft. Right? So we're gonna use this kind of thing here. You know that the inverse Laplace transform of s minus 1 is e to the t, right? Which means that 1 over s minus 1 is the Laplace transform of e to the t. And I want to use this formula. How do I use it? So how can you see 1 over s minus 3 in term 1 over s minus 1 to the power 3 in terms of 1 over s minus 1? Yes? Excellent. Can you sign the back of the paper, please? So you see that this guy is the second derivative of this guy, right? Which means that here you have to take 2 times the derivative. Okay? Now I'm gonna apply this formula. So I have 1 over s minus 1 prime. So this is in 3.1.2, right? So I have 1 over s minus 1 prime will be minus 1 of what? I want to apply this formula, right? So I have fs is Laplace transform of f. So f prime will be minus Laplace transform of t times f. So what is the small f in this case? This is the capital F, right? This is Laplace transform of some function. Right, so what is the small f in this case? Yes?
T times e to the
Right, so can you say at the back of the paper, please? You're going to apply that formula for ft to be e to the t. Right? So 1 over s minus 1 is the Laplace transform of ft, and ft is e to the t. Alright? Now I take the derivative of this guy. What do I get over there? Minus the Laplace transform of what? Yes?
T e to the t.
Can you say the back of paper, please? So this is t e to the t, right? So this is t times ft, right? So which means that here I have 1 over s minus 1 square minus Laplace transform of e to the t. All right? It's clear. So I have 1 over s minus 1 is the Laplace transform of e to the t. I apply that formula for the function ft to be e to the t, which means that this derivative will be minus the Laplace transform of t to the t. So this derivative is minus 1 over s minus 1 square, which means that now I have 1 over s minus 1 square is going to be Laplace transform of t e to the t. But I want 1 over s minus 1 cubed. So how do I do? You know it already. How do I do? Now I have 1 over, yes?
You just do the
Yes, can you say the back of the paper, please? Now I'm going to do it again. So I have s minus 1 square prime will be, so what is the right hand side here? I want to apply this formula. Okay, so what is the value that I have here? This is going to be minus the Laplace transform of 1. Yes? Inside the back of paper, please. So this is going to give you t square e to the t, right? So this guy is again 1 over s minus 1 to the power 3 minus with a 2. And then this is minus Laplace transform t square e to the t. All right? So which means that 2 over s minus 1 to the cube is going to be the Laplace transform of t square e to the t. All right? So which means that 1 s minus 1 to the 3 is going to be the Laplace transform of t square e to the t over 2. All right? It's clear. So what is the inverse Laplace transform of this guy? So 1 over s minus 1 to the power 3 will be Laplace transform of t square e to the t over 2. What is the inverse Laplace transform of 1 over t minus 1 to the power 3? Right, so I want to, what is it? So I have a function is the Laplace transform of another function, right? What is the inverse Laplace transform of this guy? Yes?
You'll just be taking an inverse Laplace transform of a Laplace transform, so the inverse of that function on the left will just be t squared times e to the t over 2.
Yes, can you say the back of paper, please? It's going to be t squared e to the t over 2, right? So the Laplace transform of this guy is 1 over s minus 3, s minus 1 to the power 3. So the inverse Laplace transform of this guy should be the other one. because this is a 1, 1. So you have only one Laplace transform for a function, and you have only one inverse Laplace transform for a function. I explain again. So in this case, you have a function which is quite difficult. You have 3 over s minus 1 to the power 3 plus 1 over s minus 1. So the first thing that I do is I do the easiest thing first. I split it to one easy thing and one difficult thing. I know that the inverse Laplace transform 1 over s minus 1 is e to the t. Now I'm going to use this formula in 3.1.2. So this formula said that if you have a Laplace transform and you take the derivative of this guy, you get minus the Laplace transform of t times the function f. I apply this formula again to this place here. So I know that 1 over s minus 1 is the Laplace transform of e to the t. I apply this formula for the function ft, which is e to the t. So the derivative of this guy will be minus the Laplace transform of t times the function fc, and ft is e to the t. So here I have minus the Laplace transform of t e to the t, right? This derivative is minus 1 over s minus 1 square, and this is minus Laplace transform of t e to the t, which means that 1 over s minus 1 to the square will be Laplace transform of t e to the t. Now I apply this formula again with ft to be t e to the t. So when I apply that again, I get the derivative of the left hand side will be minus the Laplace transform t squared e to the t. So this derivative is minus 2 over s minus 1 to power 3, which means that minus 2 over s minus 1 to power 3 will be minus the Laplace transform of t squared e to the t. Which means that 2 times s minus 1 to the power 3 will be Laplace transform of t squared e to the t. Now I divide both sides by 2, I have 1 over s minus 1 cubed is the Laplace transform of t squared e to the t over 2. Which means that if you take the inverse Laplace transform of this guy, you have to get back this guy, right? So now I'm going to plug everything back into the equation. So what is the final answer? I have the inverse Laplace transform of 1 over s minus 1, and I have already the inverse Laplace transform of 1 over s minus 1 to the power 3. Yes?
Well, we know from the first term there that we can just pull the, that term. We know we can just pull the 3 out because it's a constant, and then we'll see that we just have the inverse Laplace transform of 1 over s minus 1 to the 3, and we already calculate that over there. So that term will be 3 halves times t squared times e to the t, and then the second term that we're taking, the inverse Laplace transform, is easy. That is just e to the t.
Yes, can you sign the back of the paper, please? So now I can put the 3 here, right? So basically this gives me 3 times of that guy. So this is 3 times of 1 half of t squared e to the t, and then this guy I know it. So this is e to the t, and this is the solution, right? All right. So the 3 here is a constant. I can put it outside, and I have the inverse Laplace transform 1 over s minus 1 to the 3. This guy is computed here. This is t squared e to the t over 2, and the last one is e to the t. Questions? This is difficult problem, but you have to know this formula. This is formula 3.1.2. Any questions? It's clear? Right. So let's continue. So example, you have y second plus 3y is sin s of 5t 0 is equal to y prime, and this is also 0. Right? So in this case, we have the sinus on the right hand side. Of course, again, this can be solved by using the method of undetermined coefficient, right? So you guess for the particular solution, but in this case, let us try to solve it by the Laplace transform. The first step that I do is I Laplace transform both sides. Right, so what is the Laplace transform sinus 5t? Yes?
It's equal to 5 squared, which is 25 over s squared plus 5 squared, which is also
5 over, there's no 25.
Oh, yes, thank you. It's 5 over s squared plus 25.
And you sign a bunch of paper, please. Right? So the Laplace transform sinus 5t is 5 over s squared plus 25. Right? Now, I'm going to compute Laplace transform y second plus 3 Laplace transform y is equal to 5 over s squared plus 25. Right? Now I have to compute the Laplace transform y second. What is it? Yes?
Is it just Laplace of y if it's y prime and y if it's 0?
Can you send back the paper, please? So this gives me s squared Laplace transform y minus s y prime 0 minus y 0. Right? And because everything is 0, so this gives me s squared Laplace transform y. All right? Right? So I apply the formula. I have the Laplace transform y second is s squared Laplace transform y minus the other things. These things is 0 because of the initial condition. So finally I have s squared Laplace transform y. This is the next step. Yes?
You plug back into the original equation?
Can you sign the back of the paper, please? So I plug everything back into the equation. I get s squared Laplace transform of y plus 3 Laplace transform of y, and this is equal to 5 over s squared plus 25. Right? So what is the next step? Yes? Can you sign the back of the paper, please? So I factorize out, and I have 3 s squared plus 3 Laplace transform of y is 5 times square root of s squared plus 25. So then I have Laplace transform of y is 5 times s squared plus 3 s squared plus 25. I explain again. Here I take the Laplace transforms of both sides. The Laplace transform sinus 5t is 5 over s squared plus 25. All right? The right hand side is Laplace transform y second plus 3 times Laplace transform y, right? So the Laplace transform y second gives me s squared Laplace transform y. I plug this back to the equation. I have s squared Laplace transform y plus 3 times Laplace transform y is 5 over s squared plus 25. So here I have s squared plus 3 Laplace transform y 5 over s squared plus 25. Which means that Laplace transform y is going to be 5 times s squared plus 3 s squared plus 25. So y is reverse Laplace transform of this guy. This gives me 5 over s squared plus 3 s squared plus 25. So how can I compute this guy? Yes?
Let's split it up into partial fractions. Which form is a over s minus s plus square root of 3, then b over s minus square root of 3, and then cx plus d over s squared plus 25.
Yes, can you sign back the paper, please? So now I'm going to split it, right? So I have s squared plus 3 s squared plus 25 is equal to A s squared plus 25 plus B s squared plus 3. Right? So what is the next step? Yes?
To factor the denominators again at 8 plus 5 times.
Can you say it like a paper, please? So now I have 5 is equal to A s squared plus 3 plus B s squared plus 25. All right? So what is the next step? Yes?
Distribute A and B and then set S equal to 0 to solve.
Yes, can you say it back the paper, please? Now I have to distribute, right? So I have 5 is A plus B s squared plus 3A plus B times 25. All right? This time you have to solve the equation. You can set s squared to be minus 3. Here I have 5 is A s squared plus 3, B times s squared plus 25. So I'm gonna distribute. So here I have s squared. So this is A plus B s squared, and then here I have 3A plus 25B. Right? So on the right side I don't have s squared, so A plus B has to be 0. And then on the right hand, and which means that 3A plus 25B has to be 5. Right? It's clear? Because on the left hand side I don't have s squared, but on the right hand side I have s squared. So which means that this coefficient has to be 0, and the other term is 5. So how do I solve this system? Yes?
You can say that A equals negative B and then substitute.
Yes, can you sign back the paper, please? So A plus B is 0, means that A is minus B. All right? So I replace this into the second equation. So this is minus 3B plus 25B, and this is 22B. So B is 5 over 22, and A is minus 5 over 22. Right? So which means that Y will be the inverse Laplace transform of minus 5 over 22, 1 over s squared plus 25 plus 5 over 22 over 1 s squared plus 3. Right? So, which means that here I have minus 25, 5 over 25, inverse Laplace transform of 1 over s squared plus 25 plus 5 over 22, inverse Laplace transform of 1 over s squared plus 3. Right? I explain again. So here, the trick is to split 5 over s squared plus 3, s squared plus 25 to be A over s squared plus 25 plus B over s squared plus 3. Which means that 5 is A s squared plus 3 plus B s squared plus 25. So I'm gonna group A s squared plus B s squared. This is A plus B s squared, and the other term is 3A plus 25B. Right? So in this case, A plus B has to be 0 because the left hand side doesn't have any s squared, and which means that 3A plus 25B is 5. I solve this system, I get A is minus 5 over 22 and B is 5 over 22. I plug everything back into the equation. So this gives me the minus 5 over 25, the inverse Laplace transform of s squared plus 25. And the second one is 5 over 25, the inverse Laplace transform of 1 over s squared plus 3. So what is the inverse Laplace transform of the first guy? Yes?
You can move the 5 from the fraction into the inverse Laplace.
Yes?
And then that will have the form of sine 5t.
Can you sign the back of paper, please? So this gives me minus 1 over 22 sine 5t. And what is the inverse Laplace transform of the second guy? Yes?
Well, we need a square root of 3 in both we need it on the top in order to use our formula for the sine.
Mhm.
And so we can multiply top and bottom by the square root of 3. And so then the inverse Laplace transform will come out to be, so it'll be 5 over 22, and then times 1 over the square root of 3, and times the sine of square root of 3 times t.
Can you sign the back of paper, please? So this gives me 5 over 22 square root of 3 sinus of square root of 3t. Right? Right? So here, I have 1 over s squared plus 25. I want to use the sinus formula, so I multiply here by 5 and I divide here by 5. So 5 over s squared plus 25 has the inverse Laplace transform of the form sinus 5t. Here this is the same. The thing which is missing is the square root of 3. So I multiply square root of 3 here and then divide by square root of 3 here. So what I get is 5 over 25 square root of 3 sinus square root of t. Questions? Screen? So we still have 3 minutes. So let us consider another example. I have y prime second plus 3y is 3 sinus of 2t. And then y0 is 0. This is also y prime is 0. Right. Now I have to do the Laplace transform on both sides. So Laplace transform y second plus 3y is Laplace transform of 3 sinus 2t. So what is the Laplace transform of 3 times sinus 2t? What is this Laplace transform? Yes?
It will be 3 times 2 over s squared plus 4.
Yes, can you send back the paper, please? So this gives me 3 times 2 of s squared plus 4. So this is 6 s squared plus 4. Right? Explain again. For this equation, again, what we do is that we Laplace transform both sides. Now, this is an equation that we met before, right? So in order to solve that, you can use the method of an undetermined coefficient. You can guess a particular solution, and then you solve homogeneous solution and equation, and then you take a sum. So, but in this case, we're gonna use the Laplace transform. So I Laplace transform both sides, and the Laplace transform of 3 times sinus 2t is 3 times 2 over s squared plus 4, and this is 6 over s squared plus 4, right? Right, so the next step is going to be Laplace transform y second plus 3 times Laplace transform y is 6 times over s squared plus 4. All right? So what is the Laplace transform y second? All right, so we continue on. Okay, yes?
S squared times Laplace transform of y minus s times y minus y prime 0.
Yes, can you send back the paper, please? So basically, you have s squared times Laplace transform of y minus s, y0, minus y prime is 0. And all of those guys will continue on Thursday. So on Thursday, we're going to solve the practice exam. So we have 2 of them. We're going to do that